Now we're going to learn how to find the vertex of a quadratic equation that is in factored form. As a reminder, the vertex is the turning point of the parabola. We're also going to look at something called an axis of symmetry. If you've noticed a parabola is symmetric, there's a line that it could be flipped across and it would land on top of itself. The axis of symmetry is that imaginary line that goes right through the center of the parabola. And the equation of the line, because it's a vertical line, it's an x equals equation, and the equation is x equals the x-coordinate of the vertex. Our essential question: how do you determine the vertex of a quadratic equation in factored form? To find the vertex, we first need the zeros. So remember, the zeros are the x-intercepts, or the x values when the function is equal to 0. So when we replace y with 0, we set up that zero product property, setting each of those binomials equal to 0, and then solving for x. Our first equation adding 3 to both sides, and our second equation subtracting 1 from both sides. When our goal is finding the vertex, you don't need to put those in parentheses because it'll be easier to use them for our next step if they're just numbers and not as an ordered pair. Once we have the zeros, we find the axis of symmetry. To do that, remember it's an x equals equation. You take those two x values that you just found, you add them together and divide by 2. Essentially, you're taking the average of your zeros, or the average of those x-intercepts. 3 plus -1 is 2, divided by 2 is 1. So our axis of symmetry is the equation x equals 1. And finally, we can use that to find the vertex. Once you have the axis of symmetry, that is the x-coordinate of your vertex. So you substitute that back into the equation for x, and you solve for y. 1 minus 3 is -2. 1 plus 1 is 2. Notice how those numbers are the same, they're just opposite signs. That happens when you're finding the vertex. If you are finding the vertex and you get two different numbers inside the parentheses, you probably found the wrong axis of symmetry, and you'll want to go back and check for your mistake. And then finally, we write the vertex as an ordered pair. We substituted 1 into our equation, and we solved and got -4 for the y value. So that would be the turning point of our graph. Taking a look at example 3, repeating that process, the first thing we need to find are those zeros, or the x-intercepts, or where the function is equal to 0. So even in that f of x notation, we simply replace that with 0. Again, 0 cannot be negative, so we ignore that negative sign. We just set what's in the parentheses equal to 0 and solve each equation. Our first equation will add 5 to both sides, and our second equation we add 7 to both sides. After we have the zeros, we find the axis of symmetry. That is where we average out those x-coordinates. So we take 5 plus 7, divide it by 2. 5 plus 7 is 12, divided by 2 is 6. So our axis of symmetry is the equation x equals 6. And finally, we can use that x value to find the vertex. We substitute that x value into the function in place of x. Don't lose the negative sign now. And then we had x minus 5 and x minus 7 for our two binomials. Keeping that negative sign on the outside, 6 minus 5 is 1. 6 minus 7 is -1. Notice those numbers are the same. They just have opposite signs, so that's a good sign. Negative times 1 is -1, times -1 is +1. So my vertex this time, my x value was 6, and I solved and got 1 for y. Here you got a you-try question. Make sure you come to class with this attempted so we can find and fix any mistakes that you might make.